Hello, welcome to the first part of my bookshelf tour. This is for the books that I am currently doing and the ones for which I have not found a place yet. After that, I will go to my actual bookshelf. So the first one is this one, House of Leaves by Danilevsky. It's a novel. I got this from Tulip's recommendation. It's an entropic novel. And it's very weird. It's a rather weird book. You really have to struggle through it. It's extremely interesting to read. But yeah, it's a novel, it's not a textbook. The second book is this one, Principles of Harmonic Analysis by Deitmar. It's a pretty rigorous book, and it deals with harmonic analysis on groups in general. So let's see what we have here. We have Banach algebras, duality of abelian groups. We have compact groups, integrals, Heisenberg group. It's very analysis, but it's a kind of mix between analysis and algebra. Then we have here one of my favorite books is Information Theory by Cover and Thomas, and it deals very thick book dealing with information theory and all kinds of applications to biology, to statistics, and everything. Here we have Spectral Theory by Borthwick. It's all about function analysis and basic spectral theory, and it has plenty of applications. So the spectral theory on manifolds, Schrödinger operators. So if you're going to do function analysis and quantum mechanics, this is really a book that you will want to be doing. Here we have Heavenly Mathematics by Van Brummelen. It's about spherical trigonometry, and it deals a lot with it's very beautiful. It deals with trigonometry through history and how they dealt with it in ancient Greece and Islamic times. For example, this contains a formula and a derivation for how to derive the Qibla, which is the direction you need to pray to go to Mecca. This is the book that I want to do with Abdul once he gets enough trick, and Andrew also, I think, should be very interested in a book like this. Here we have Mathematics in Aristotle by Heath. It's all about, Heath is of course the great historian of the Greek times, and yeah, this is all about what Aristotle did. I think I have all Heath's books, or at least most of them. Here is Inventing Temperature, which is all about what temperature is and how it was invented and why it was invented. And yeah, all about the history of thermodynamics and the concept of temperature. Then we have the conceptual framework of quantum theory, quantum field theory by Duncan, which is a book I started reading, but which is at the moment a little bit too difficult for me, because I'm unfamiliar with the way they do the math. Like the math, I know the math in terms of mathematics, but they have a different focus, obviously. More specifically, group theory and Lie group theory. I'm not that much familiar with that anymore, at least. Here we have Electrodynamics and Classical Theory of Fields and Particles, Barrett. A very good, concise book, but not the not the easiest one. I have a few quantum classical field theory books, and this is one of my favorites. Here we have Quantum Field Theory by Telegraph. Telegraph is a Fields Medal winner, who started to write a book on quantum field theory from a mathematical perspective. It's very interesting, very beautiful. But it's very much a mathematical perspective. So it's very much something that a mathematician would be interested in, and I'm not sure how physically good it is, given that the guy's not a physicist and doesn't really know much of physics. Well, he's a Fields Medal winner, so I'm sure he's good. Then we have here Bressot's A Radical Approach to Real Analysis. Is really a beautiful book for real analysis, and it develops real analysis from a very historical point of view, and it talks about why we are interested in real analysis in the first place. What prompted it, and what prompts is, of course, physics. And it talks about everything that went on while developing real analysis, all the mistakes that people made, all the dead ends that people went through. And it goes through everything that was needed to develop real analysis. It can be followed up by his other book, which I'm going to talk about later. Here is Reef's Statistical Physics, which is an undergrad statistical physics book. This is nice. This is a nice book. This is an extremely nice book because it really talks about statistical physics in intuitively. Chapter 1 is a very intuitive way of dealing with statistical physics and what heat means, what molecules is, what entropy means, from a very intuitive point of view. And it actually derives all of statistical physics. You see here entropy, see here the equipartition theorem. Everything is done. It starts from scratch, and it's a very nice molecular point of view, basically. Here we have Feller's probability theory. And Feller's probability theory is a very rigorous book, but not measure theory rigorous. It's just probability theory without measure. But there's a lot of really neat exercises. I want to work through the book with Krim because I think he'll love it. But obviously he's not that keen on it. And here we see a lot of combinatorics problems, which are pretty nice. I'm trying to work through every single problem in this book. Because I think they're really fun, even if they're combinatorics problems, they're really fun. Yeah, I see. This is a gem of a book, but it's not the first book of probability you could ever see. But it's really a gem. It's really beautiful. Sadly, it has some analysis, so maybe Krim won't like it after all. Here we have one of my prides, a book I discovered recently to work through with Martin. Burkle, Classical Analysis in the Complex Plane. So it's a very historically motivated view of complex analysis. See how thick this book is. It is absolutely massive. And it has a lot of good stuff. It has a lot of beautiful stuff. But it is very much a classical analysis book. So you'll see stuff like the Riemann mapping theorem, yes, but not really manifolds. So you see here simple and double connectivity, ideal singularities, all of classical analysis, and not really from a modern perspective, which honestly I really appreciate. I'm not sure I really like the modern perspective that much. Here we have also a good book. You have Wilcox, Basic Fluid Mechanics. And Basic Fluid Mechanics, well, it's an engineer book. It's a book for engineers. But it does three things with decent mathematical rigor. Here we have, for example, dimension analysis, where it treats the Buckingham pi theorem, which is extremely nice on dimension analysis. And you see a lot of it. It really is a nice book. It really is a very intuitive, very physical. Even for engineers, it's very, very neat. Here's Hill, an introduction to statistical thermodynamics, which is basically statistical mechanics from axiomatic point of view. So it's an old book, and you do notice it's quite an old book, and it's not that easy to read, honestly. It definitely shouldn't be your first book on thermodynamics, but yeah. Introduction to the history of algebra. Well, which is what it says. It's about algebra and the history and how algebra was basically invented. So it goes on from the Babylonian period, from the Ephantes to the Arabs and everything. Solution of the cubic formula in Italy, where it kind of ends. Here's the second book of Bressot, which is all about Lebesgue theory. It's basically a second sequel to his reanalysis book, and it starts with how Lebesgue integrals are done from the ground up, historically. And it deals, one of a few things it does is, for example, it deals with Cantor's theory, it deals with, a lot of things which come from Fourier series. Another book I really like, Zacchary's A Course in Complex Analysis, which does things from a very modern point of view, from a very topological point of view, too. Things are done exactly right topologically, exactly right from analysis. So they really take the most advanced point of view here. So they do things like homology and homotopy and very nice stuff that you don't really find in many intro books, but which is of course well known to experts. Here we have Ilgert and Neep, Structure and Geometry of Lie groups. If you want a book on Lie groups, this is the book you want. It has everything. It is absolutely massive as well. So it's very nice. It has parts on Lie groups. It has structure theory on Lie groups. It has Lie algebras, manifolds. If you're interested in Lie algebras and Lie groups, you're gonna find it here. It's a really nice book. Here we have a book on function analysis, a linear and nonlinear function analysis with applications by Charlotte, which I was most interested in because it dealt with nonlinear function analysis, which you don't really find that much. So here you see partial differential equations, you see applications to nonlinear function analysis, differential geometry in Rn, for example. Every single thing of the good stuff is done here, basically. Thermal Physics by Goodstein. You all know, by Goodstein. This is a book on thermal physics, basically, and how thermal physics is done. It's a pretty well written book. Goodstein is a really good writer. I really like the writer. Physics and Music, the Science of Musical Sound, is on, like it says, it's on music theory, and how music theory arises from physics. There's square law, so everything is done. So it's, it deals with how sound is made and what music is. Basically the physics behind how you make sounds and everything. And then we have here a story, Thermodynamics and Statistical Mechanics, which is basically should be a first book on thermodynamics, or on temperature. But it does require you already to know, like you see here, quantum mechanics already a bit. But yeah, it's a pretty advanced book already. Here we see Keohane and Foy, Classical Electrodynamics, which is basically a book which deals with electromagnetism from historical point of view, and a lot of talking about the original experiments and why they did what they did. It's a very nice book, but it's not good as an introduction, which makes me kind of sad, because that's what I was hoping for initially. Algorithms and Computations of Krauth, which, like it says, it's about different kinds of algorithms in statistical mechanics in particular. Logical design, so it's about design of gates. So we see latches, flip-flops, register, counters, multiplexer, decoders. So it's about the architecture of gates and of circuits and of computers, Boolean algebra. A very engineering book, but if you want to see how Boolean algebra is useful and how computers are made, this is a really nice book. Then here, Introduction to Acoustics, which is all about the science of sound and how to make sound reflects optimally.